March 16th, 1978, on the beautiful shores of Brittany, France, an oil tanker leaks and spills 70 million tons of oil into the surrounding sea. That's enough to fill 100 Olympic-sized swimming pools. One of the main tools scientists use in the cleanup of this oil is, can anyone guess? Dish soap. Dish soap. What? Yes, dish soap. Literal tons of dish soap. Before we can answer the question of why one of the most important weapons for scientists when it comes to oil spills is dish soap, first we have to ask the question, why are oil spills so dangerous in the first place? So today, we're going to talk about oil spills. But before we start, let me introduce myself. Hey y'all, my name is Jacob Weissman. I'm a student at Queens College. I have 7 siblings. That's a lot of people. That means I'm one of 8. It's a lot of people. I can pat my head and rub my stomach at the same time. I hold the world record for fastest time solving a 1x1 Rubik's Cube. So you have the 3x3s, you have the 5x5s. I do the 1x1. That's my zone, 0.000 seconds, which might not sound impressive and you might think it requires no skill, but why don't you try to beat it? Today, we'll be looking at oil spills and how to clean them up. So first we're going to talk about oil spills, and then we're going to actually examine the properties of dish soap and oil and water together by making dish soap lava lamps. And all the while that we go, I want you to think about what are some things you know about oil and water, and I want you to think about mixing, and what kind of creatures do you think are impacted by oil spills? So again, our original question, why is an oil spill dangerous? This is a picture of an oil tanker exploding in grand fashion. Equipment malfunctions, old machines breaking down, or human error can be the cause of any one oil spill. Obviously, that explosion in the picture is not going to be good for anyone in the surrounding area immediately after it happens. But why is oil itself leaking into the ocean so bad? Before I hit the button and go to the next slide, which has the big answer, I want you to think about what's something that you know really gets hit hard by oil spills. So everyone think of something, and let's see what it is. Wildlife. That's the big area that gets hit by oil spills. They have a lot of short-term effects and a lot of long-term effects on wildlife. Short-term, sea creatures can inhale oil. You're plopping a lot of oil into an ocean where they're used to just swimming around and breathing and inhaling water. Now you're putting oil there. That can be really dangerous, especially think about if you're trying to breathe and someone sticks a cup of oil in your face and doesn't let you move. That's going to be an issue for you, the same way that it's an issue for these creatures when oil gets dumped into their ocean all of a sudden. Sea creatures can also get stuck. Imagine a baby turtle. It might not have the muscle to get itself out of oil once it gets stuck in. So now you're plopping tons of oil on its head. It's not able to get out of that oil. Sea creatures can also freeze. A lot of creatures have specific mechanisms for dealing with situations that they're used to. So for these warm-blooded creatures, they're used to warming themselves in cold water in the specific ways that they know how in cold water. That doesn't necessarily work when it comes to oil. So oil could really disrupt these animals' processes. And by disrupting the processes, it can cause them to freeze. And that ultimately leads to death. And oil spills do kill thousands of all types of creatures, from birds to fish to sea otters to whales to turtles to dolphins. Across the board, all kinds of sea creatures die when we have major oil spills. Long-term effects can be more difficult for us to pin down when it comes to oil spills. And that's the case with a lot of things. It's hard for us to keep track of all these creatures and their lifespans and their issues that they faced because of the oil spill. Short-term, we can do a body count, but long-term, we can't possibly know every single thing that's happened to every creature. But what we do know is that long-term oil spills cause growth issues, heart issues, and development issues in surviving creatures, which kind of makes sense because you're exposing these creatures to a substance that they're not used to seeing in their everyday life, and they're now inhaling this and swimming in it. That can cause serious issues. These creatures can also a lot of times become unsafe to eat for humans, which causes a problem for the food industry because now they have another thing to worry about, is vetting and making sure that the creatures they're serving humans are not overly exposed to something like oil after an oil spill. Ultimately, we can't possibly know how many creatures oil spills do kill long term, because we can't do a precise body count, but we do know that it does kill a lot of creatures and it causes a lot of damage to habitats and ecosystems. Clearly, oil spills cause major, major problems for the ecosystem where they take place. But what kind of things can we try to do to limit the damage of the oil spills on the ecosystem? So we have three main strategies: skimming, burning, and dispersion. Skimming is when we pool together oil on the surface and then we scoop it out. Burning is when we pool together oil on the surface and we light it on fire. I personally would enjoy burning more than skimming. Once I'm already going through all the trouble of pooling together the oil, I'd rather just light it on fire. That's me. I don't know. Dispersion is dropping dispersants like dish soap onto the spill. Disclaimer, it's not necessarily literal dish soap that scientists go and buy from the store, but the chemicals used for dispersion can also do share the same properties as actual dish soap when it comes to dispersion. So dish soap could theoretically be used in place. Now, why dispersion? What makes dispersion effective in treating oil spills? I understand skimming and burning, but dispersion, what? I'll give you a hint. It has to do with the original question we asked, which is what do water and oil refuse to do when combined? Now, hint number two, the answer to that question I just asked, hint number one, is right behind that bottle of soap there. Oil and water do not mix. No matter how hard you mix them together and no matter how hard you shake them, water and oil will always separate because oil is hydrophobic, which means it does not want to mix with water. It will repel water, and oil's happy being next to oil and it's unhappy being next to water. Dish soap molecules have one end that bonds to the oil and another end that's attracted to water, which is hydrophilic. So they kind of encapsulate oil inside a bubble. So you have hydrophobic oil on the inside, then you have hydrophobic soap molecule, then the hydrophilic end, and then that's all surrounding the oil molecule, which allows it to dissolve into the water. So now oil and water couldn't mix without dish soap. With dish soap, it's a lot easier for oil and water to mix and stay mixed for longer. Okay, so here we have an actual diagram of what I'm talking about. So you have the oil particle in the middle, then you have the hydrophobic parts of the soap molecule. It's that little string part. And then finally at the end, you have the circle part of the soap molecule. That's the hydrophilic part, which allows it to dissolve in water. So surrounding the entire oil particle is that end of the soap molecule that's able to dissolve in water. And that allows the oil particle on the inside to itself dissolve into the water and mix better and stay mixed for longer. Now let's reflect. First of all, why are oil spills dangerous? I'm going to give you a few seconds to answer each of these in your head, and then I'll say the answer. So oil spills are dangerous because they cause a lot of short-term and long-term issues for ecosystems. Short-term, they can kill thousands of creatures. Long-term, we don't even know how many creatures they kill, but we do know it causes growth issues and development issues for creatures that are impacted by oil spills. Number two, how does soap help us deal with oil spills? So soap helps the oil dissolve into the water, which spreads the oil and ultimately limits the damage. And that's the key. When we have an oil spill, we have a ton of oil in one spot. We're trying to get the oil out of that spot. So we can directly take it out of that spot, or we can use soap, and soap will allow it to mix around, and that'll really lessen the impact and limit the damage of the oil spill. And number three, how can we prevent oil spills in the future? Now, I'm not actually going to directly address this one because I want you to leave and think about that. How can we improve our processes to prevent oil spills in the future? I already said oil spills are caused by equipment malfunctions, machines breaking down, and human errors. So what are some things we can do to prevent these steps from happening and then ultimately prevent oil spills? Now let's get into the lab and let's apply what we've learned. We're going to be making our very own lava lamps to observe the properties of water, oil, and dish soap. Materials we need: oil, water, a measuring cup. If you don't have a measuring cup, you can use a clear water bottle, or you can use a clear cup. but I do recommend the measuring cup because it's best to see the effects through a measuring cup. It's the coolest. Dish soap, syringe. If you don't have a syringe, you can use a old shampoo bottle or a pipe cleaner. But again, it's going to be easiest to do this experiment with a syringe. A spoon for mixing, food coloring, paper towels just to clean up, and several plastic cups because we are going to be pouring different liquids into different spots. So we're going to need some plastic cups along the way. Safety rules. This is a pretty safe experiment to do, so there's not that much. It's just listen to the instructions, especially if you want the lab to go as well as possible and the effect to be as cool as possible. Keep your hands and all material away from your eyes, goes without saying. Do not run. You don't want to spill anything, and pour materials carefully. Again, don't want to spill anything. So dish soap lava lamp. First procedure, we're going to pour 1 cup of water into a measuring cup. It doesn't have to be exactly 1 cup, and actually I recommend that you make sure that whatever size cup you're using or bottle or measuring cup, you don't fill it up more than halfway, because if you fill it up halfway with water and halfway with oil, then you're going to be at a full cup and it's not going to be easy to stir it. So just maybe do a third of the way with water and then a third of the way with oil. And by the way, oil, any oil works for our oil. So pour 1 cup of water into the measuring cup, then pour 1 cup of oil into the measuring cup, and do not mix. I can't stress that enough. If you mix it, it will separate, but you'll also it'll become cloudy and it'll be hard to see the effects that we're going for with the soap. So I'm going to mix it on my own, and I'll show you that it'll separate by itself so that you could trust that and then not have to actually mix it yourself. At the end, you can mix it together if you want, but for now, don't mix because we want this to be as cool as possible. Okay, so here in this picture, we have all our materials in front of us. We have a cup of water, a cup of oil. We have our measuring cup in the bottom left corner. We have our cup of dish soap, which is hard to see because the dish soap is clear that I'm using. That's the cup in the middle bottom. And then I have my syringe, I have my food coloring, and I have my spoon and a paper towel. Okay, by the way, for the food coloring, you're going to want to use a red, blue, or green food coloring, not yellow, because yellow food coloring, you won't be able to see the effects so well. And for the syringe, I forgot to mention, you can use an old hand sanitizer bottle with the times, which will give you good drops if that's how you want to dispense the dish soap and food coloring combination. Okay, now I did say that I was going to demonstrate that water and oil don't mix. So here we have a bottle of water with oil on the top. We're going to shake it up, and we're going to see that the water and the oil do separate. And I'm going to put it in fast motion right here. Give it time to separate. This is on 20 times speed. And after about 2 minutes, when we look back at the water oil bottle, we see that it has reseparated. So again, no need to test this with your own measuring cup. Don't try mixing it so that we can see the best results we can. Water and oil, clearly do not mix. Okay, so we're going to pour our water in to our measuring cup. Then we're going to pour our oil in. And now take the time to pause it and pour your water in and your oil in, and then we're going to get to the next part. Okay, so now that we have the water and oil in a cup together, in a separate plastic cup, we're going to mix dish soap with food coloring. Okay, food coloring should be either red, blue, or green. Don't use yellow, because if you use yellow, you're, again, not going to be able to see the effects as strongly because it's yellow. It's going to be yellow on yellow. Soak the mixture into the syringe and release droplets into the water/oil measuring cup. What I mean by that is just suck in with the syringe and then just let little drops go and observe. It should come out really cool. You should have little drops, little color drops floating through the oil, floating down the water, bouncing off the bottom of the water. It's going to be very cool. And I'll show you an example of what my results were in case you didn't achieve it, or if you just want to know what it's supposed to look like. Okay, so now we're going to take our food coloring and we're going to give a few drops into the detergent cup, the dish soap cup, sorry. And then I'm going to mix it together with my spoon. Now, I don't actually mix that fast. That's triple speed. I'm not a speed mixing demon. Now that it's all mixed, we take our syringe and we suck in with the syringe. You might need an adult to help you with this because it is challenging to get a thick substance like dish soap into the syringe. But once we have it, we're going to go on top. Now, pause it now if you want to do the experiment yourself without seeing what mine looked like, okay? So pause now. Come back afterwards if you want to do that. If you want to see what mine looked like first, then continue watching. Or if you've already resumed
now come back. And this is what my experiment looked like, is you kind of see those drops of soap sliding through slowly, kind of suspended in the oil. And then my cup had just been washed, so some air bubbles are there in between the oil and the water, which is why I'm seeing a little bit of delay in the effect of the soap surrounding an oil molecule, and then that whole structure just falling through the water really slowly, like a lava lamp kind of look. But it does come. It'll come in a few seconds. Right now, it's just kind of cool to see the dish so slowly making its way through the oil. And then this is the top view of it, what it should look like. We're just spraying dots all around. And then when it does come through the bottom, you're going to see so these big blobs that we have coming down are oil being surrounded by dish soap, and that whole thing is softly floating through the water, which is really cool to watch. Again, it's a lava lamp kind of look. And you could just watch it floating in, bouncing up and down a little bit. It looks really cool. Obviously, if we didn't have the oil, just using dish soap and food coloring and water, we can't get this kind of look. This look is created by the fact that we have the oil molecule inside of like a soap bubble, so to speak, and that whole thing is floating down through the water, and that's what's allowing the oil to look. There's literally oil sitting on the bottom of that cup, and it's fine just being there because of the soap that's allowing it to dissolve.
Okay, let's consolidate. Based on the results of the experiment, why might dish soap be an effective tool against oil spills? Okay, so now that you've had a second to think about it, the whole key with oil spills was let's limit the damage, let's spread the oil around when it comes to dispersion. So dish soap, if you paid attention, you saw the dish soap when you dropped it in with the food coloring, it kind of went down to the water and stayed suspended in the air, so to speak, while it was in the water, that was actually an oil molecule being surrounded by soap, staying suspended, because what we have is the soap has two ends, a hydrophobic end and a hydrophilic end. The hydrophobic end is going to be attracted to the oil, and the hydrophilic end is going to go to the water and allow the oil to dissolve. So what soap does is allows oil to dissolve into water more effectively and keep it mixed together, and also allows it to fall beneath the surface, as we saw if you dump it on top, which is both going to be effective against oil spills. Question 2, why do water and oil stay separated? Why does dish soap help them mix? I'm going to take a second to think about that. So a lot of people say that oil and water don't mix because they're different densities. That's not true. Different density substances can still mix. Water and oil won't mix because oil is hydrophobic and water is hydrophilic. So oil only wants to stay with other hydrophobic particles, which is oil if you put the two in a container together, and water wants to stay with water. They don't want to mix together. They'll repel each other. So dish soap, it kind of turns the oil into hydrophilic because it disguises the hydrophobic in a hydrophilic shell. So you have a hydrophobic middle, then a hydrophobic end. The dish soap molecule continues to a hydrophilic end, and then that's all able to dissolve into water. That's how dish soap helps them mix. Now, I do want to clarify, water and oil do have different densities, and oil is less dense than water, which is why it stays on top of the water, but that's after the fact that it can't mix. So now that it can't mix, how do we know which one goes to the top and which one goes to the bottom? The answer is oil, because oil is less dense. Thank you for engaging, guys. I had a blast learning about oil and water and dish soap. I hope you did too. I hope we all learned a lot about oil spilled along the way and had some fun with it too. Questions and comments, I'd love to hear from you. I put my email there, jacobweissman18@gmail.com. And have a wonderful day, y'all. Peace out.